this is the work. We introduced the concept of the work. The work done by a constant force is W. Force will do work. Okay, someone has to apply the force, so you can say that someone is doing the work. But anyway, I mean, it's because of the force that the work is being done. So I can put it something like that, a scalar product of the work force with the displacement. So if the, so what it means is the what it means is, okay, unlike the vector product, this is a scalar product, it's cosine of theta. And the result is a scalar. Okay, vector product, the result is a vector, but the scalar product, the result is a scalar. So this is the how you do that. Here you don't see the theta, but it comes in when I, interpret it. It will be F magnitude, not D magnitude, and cosine of the angle theta. Theta can be anything from minus 90 to plus 90. So when it is 0 to plus 90, cosine theta will be positive. When 0 to minus 90, cosine theta will be negative. So here, the force is applied in this direction. The Superman is trying to stop it. The train is moving this way. So displacement is to the right, force is to the left. What's the angle between them? 180. Cosine 180 is negative 1. Very important, okay? You have to put it with the sign. So the work done will be negative because by the force, okay? Force is to the left, displacement is to the right. So what it means is the Superman is not rather providing energy, he is extracting the energy from the system, okay? But anyway, this question is simply the work done, whether you know the definition of the work done. So that's it. You substitute and find the answer. F is 10,000. D is 15 meters. And cosine 180. This will give you the negative 1. And when you do that, you will get the answer to be 150,000 joule. So converting into kilojoule will be 150 kilojoule. It's a straightforward question. We can, of course, translate into the law question, which is the net work. Well, the net work here will be, the work done by the Superman, also the work done by friction. If you ignore the friction, there will be friction. Then that means all the work done by the Superman is going to stop the train. No work is wasted. So if we say net work is the work done by the Superman, then it is equal to change in the kinetic energy. So you have this 150,000 here. And suppose if you know the if you are asked to find the initial speed of the train or something like that, and since this is not even used in this question, so probably his stopping mean final is 0. So from this we can find the question can be further added to find the speed as well. Okay, the initial speed. Okay, that's the question. Let's move to the next one. A 60-kilogram runner has a speed of 3 meters per second at one instant during a long distance event. What is the kinetic energy? It's also a straightforward question, okay? So we make it very easy for you, right? So if you remember, even if you don't remember, it is in the formula sheet, right? The kinetic energy is Ke, okay, equal to half. It's a straightforward definition question. M is given. speed is given, that's it. You substitute, ridiculously easy. Right? I will not bother. Number 15. Which other quantity? It's also sometimes most repeated question. So simply from this work kinetic energy theorem. So this and this should have the same unit. Energy is joule. That means work is also joule. So which other quantity is measured by the same unit as the work, right? So that's why this is the answer. All the rest are all wrong. Question number 16. A man of mass 70 kilogram performs a push-up by lifting his body from the lower position. Okay, this is the initial. So you have to be careful, okay, to mark which is the initial, which is the final. That's very important, okay? Because if the other way around, potential energy is decreasing. Here, the potential energy is increasing. His center of mass is being lifted up. So how much is lifted up? This much. Oh, no. No, wait. Initially, he is this much. Finally, he is that much. So, okay. So don't do what I did, Better read the question carefully and don't make any mistake. What is the change in the gravitation? It's also a definition question, okay? Not applying a law, just a definition. We know that from the definition of the potential energy, we give an expression for the change in the potential energy is mg delta y. It's also a direct question. All you have to do is to just substitute. M is 70, G is 9.8, delta y, only the vertical change in the position. So suppose you didn't realize which is initial, which is final, the answer can be a difference of negative, positive sign, okay? You have to be very careful. Here all is positive, so, okay, but it can happen that I will give you negative, positive, both, then, right. Delta y is y final minus y initial, right? So let me do another step here. I will not do the calculation. You can check it yourself. Y final is 0.42, which is higher, larger, and y initial is 0.20. So obviously, we're going to get this answer. I will not bother you with the calculation, so we can save time, go to the next question. Number 17. These are all this medical stuff, okay? But the question is very simple. But, just to relate to you as a medical student, so let's read it. Even under normal circumstances, forces between vertebrae in the spine are large enough to create a pressure of several atmospheres. The pressure that we are experiencing because of the air molecule hitting us, because we know above our head, it's like kilometers of air above us, right? So much like the liquid column is a fluid column of air is going to exert pressure on all around us. That is one atmosphere. We are evolved to withstand that pressure because we have the blood pressure inside our body. So we will not collapse the 1 atmospheric pressure from the air, and we have the pressure from our fluid inside, the blood, whatever. It is, we are not crushed in. So we are evolved to withstand 1 atmospheric pressure. But if you're diving, if you have done diving, I haven't, but just if you go down, you will experience, in addition to the 1 atmosphere, we also have the fluid pressure from the water. If you go 10 meters below in an ocean, it will add another 1 atmosphere. So you will be under high pressure. So that's why divers wear a special suit to withstand that pressure. Now, let us look at this. Most causes of excessive pressure in the skeletal system can be avoided by lifting properly and avoiding extreme physical activity. This pressure can damage both spinal discs as well as the bony vertebrae themselves. For example, when a person lifts an object improperly, a force of 5,000 Newton may be created between the vertebrae in the spine, and this may apply to an area as small as 10 centimeters squared. We did a question in the previously where we saw when someone is bending down, the force on your muscle can be as much as some thousands of Newton. Now here's a 5,000 Newton, and suppose that force is applied in a small area, there's a possibility because you have this disc in a small area, there is a possibility. So he is asking, if that is the case, what is the pressure? What is the definition of the pressure? Again, definition question. All these medical stuff, but the physics is very simple. The force pressure is equal to force. So don't be scared by if I give you all this, just to give you some relevance to what you are studying. Yeah, exactly. Right. And I mean, we do, personally, I just make sure, you feel appreciated. Okay. So you make the connection. So, but in exam situation, if you want to save time, if you get the idea, you can quickly go to the second part and see what the question is. So no, you are not intimidated by all these big paragraph. You're not supposed to. You're a medical student. You should feel very comfortable with that. Okay, right. So substitute units, right? Force must be in Newton, that's a SI unit, and the area must be in meter square, not centimeter square. So although I said chapter 1, 2, 3 we don't going to ask question, but if you have forgotten how to do conversion, you will be in trouble here. So that's a warning. So 10 centimeters squared, I'm not going to give you the conversion factor. You're supposed to know what is centimeter and meter, right? So 10 centimeter square. This is Newton, that is already a SI unit, no problem. The centimeter square, because we have the pressure you need to do a conversion. The pressure is not in Pascal, it is in atmosphere, but that we will do later. Let's get it in Pascal first. Centimeter squared must be converted to meter squared. So what is the conversion factor? Centimeter should go, meter should come up, right? But it is not centimeter, it's centimeter squared. 1 centimeter is 10 to the power minus 2 meters. But that's not correct, right? Because it is not going to cancel. It must be centimeter squared. So you can quickly square the whole thing up and down. So this will be 1 squared centimeter squared. Yeah. I mean, I'm trying to show it systematically. So you're squaring both up and down. When you square this will become squared, and this will become, because minus 2 to the power 2 will be minus 4, right? Okay. It is not, it is not 2 multiplied by 2. It is actually 2 to the power 2. It's happened to be the same, but don't be misled by that, okay? Because 2 to the power 2 is the same as 2 multiplied by 2. I mean, it's not twice, it is 2 to the power 2. Okay. Ten to the minus 3, right? Okay. So when it comes up, there's a 10 to the power 3 here. When it comes up, it will 10 to the plus 3. I mean, if you don't like it, you can just use your calculator and forget about the whole thing. But anyway, I just, this 10 to the power 6 Pascal. But you need the answer in atmosphere. So you have to convert that Pascal to atmosphere. So again, you do this, Pascal down, atmosphere up. So we can get the Pascal to cancel. So this says 1 atmosphere is 101.3 kilopascal, right? So that means okay, someone do it and see if we get this answer, please. Someone confirm. I don't want to have any mistake. Do you get 49? You have a calculator? Okay, let me use my calculator. Maybe I need it later, so let me get it out. Why? I thought I have my calculator here. Nothing. Someone erased my calculator. Come on, this piece, yeah, okay. Desktop. Come on. Did I lose my calculator? Ah, okay. Yeah, it's been erased. Okay, maybe they. Right, someone help me. Please tell me if you are getting the answer. It's this, right? 5. You getting it? Okay, thank you. What? Did I make a mistake? 6, right? Yeah, yeah. Okay. All right, so that's, it doesn't cancel. 3. Yeah. Anyway, so yeah, sure, it's correct. Yeah, just wanted to be sure that I did not make any mistake. So let me go to the next question. On a cold day, you take in 4.2 liters of air into your lungs at a temperature of 0 degree. If you hold your breath until the temperature of the air in your lungs reaches 37 degrees Celsius, what is the volume of air in your lungs at that point, assuming the pressure does not change? So, you can, when you're seasoned and you've done so many questions, you know what to write. But just to be on the safe side, I'm going to assume, we are just beginning to. So you don't make any mistake, you write it in full. This is a stage problem, right? You're going from one stage to stage 2. So here, pressure doesn't change. P1 is equal to P2. Oh, I should have done. P1 is equal to P2. And there is no leakage of the air. You're talking about the lungs, okay? So we keep the same amount of air in your lungs, is only the temperature is changing. So if you hold your breath until the temperature in your lung reaches 37 degrees from 0. You breathe in and take some air, which is 0 degree from outside. It's a cold country or something. And you hold it in your lungs until it reaches the body temperature, which is 37 degrees. So it's the same pressure that we are assuming here is given to us. Okay. And then he was asking, what is the volume in your air? If you manage to keep the same pressure, what will happen to the volume? So the equation is going to be V1 over T1 is equal to V2 over T2. This is the best way to approach this problem, okay? When you have a stage, you're moving from initial to final. So look at it and write it in full without making any assumption. Then slowly see what are constant. Usually the N1 is equal to N2, usually, otherwise the problem becomes more complicated, but that's it. You got this. Is V1 given? Yes, V1. And T1 given, yes. Here is a problem, right? The temperature 1, this T, just to remind ourselves, we put it in capital T, it must be in Kelvin. You cannot put it in any other units. So this must be converted to, you know how to convert. So now let me substitute values. Now this liter you don't need to convert because the answer V2 is given in liters. So we will put the V1 in liters. So that will guarantee V2 will come in liters as well. T1, it will be 0 plus to 73.15, and V2 will be 37 plus 273.15. Now, don't assume because I am adding both sides by the same number, it is going to cancel. No, they are not going to cancel. It's only a factor multiplication, it will get canceled, not for addition. I don't have the calculator. I don't know what happened to my calculator. Okay. I don't have. What do I do? Is it? Yeah. Download? No. Anyway, somebody please help me. I mean, do you get the answer? You know how to use your calculator in the in the solving mode. I just want to be sure I'm not making any mistakes. So this is the equation that has to be solved, and you should get the answer for V2 to be getting it. Okay, thank you. Let's go to the next. Which one of the following properties does not describe an ideal gas? So there are some postulates, call it postulate we use when I say something is an ideal gas. What we do, I mean, real gases are not ideal gas, but we can make some assumption. Ideal gas should follow something. One of them is no, the particles we consider a particle, there is no force between the particle. Okay. We ignore that, of course, they have masses. Real gases, they have mass. So they have big gravitational force, but it can be completely ignored. And they have no charges or an electric force either. So that's one of them. And there are other things which I can't remember now. The collision will be elastic. So no energy is lost. It is in the, because there may be question where you will not give this, but it will be another one of the properties. If anyone can open the slide, chapter, I can't remember again, 7 or something, gases chapter, and go to the kinetic energy of theory of the gases, then there will be those properties. These are not in the formula sheet, right? So you should know those properties. Anyway, can I move? Yeah, the sizes are ignored and the molecular interactions are ignored. And when they do collision, there is no kinetic energy loss or elastic collision with the walls as well as between each other. Those are the kinds of assumptions we have. Right. Anyway, I mean, you can look it up. I will continue. Question number 20. If you have an ideal gas, only for ideal gas, you prove it using the kinetic energy of theory, which based on those assumptions or postulates. Internal energy of an ideal gas depends only on the temperature. Only on the temperature. We even get the energy expression for that, which is for a monoatomic ideal gas is 3/2R, or 2/3, or 3/2. All right, let me open the formula sheet. Okay. Formula sheet, final exam. Yes. Yeah. Yeah, U for ideal gas. It's not there. Maybe in the, okay, probably I try to include it. It's either 2 over 3 RT or something for ideal gas. Yeah, the CVU for ideal gas. Right, it's not there. Anyway, okay, I'll check it later. So let me continue. So it depends only on the temperature. I'm not sure about this factor. There is a T. This is a constant. All the thing is constant, so it depends only on the temperature. Number 21, a gas is compressed from an initial volume of 25 liter to final volume of 10 liter at a constant pressure of 150 kilopascal. How much work is done on the gas? Right. So now here we come to, again, these are all in the formula sheet. Okay. So here we are talking about constant pressure. So you will see that in the formula sheet, I have categorized them, the processes when it is constant pressure, which is isochoric, when it is isobaric, right? Constant volume, isochoric, constant temperature, isothermal. So you should go and pick the right equation for your question. So this is when the pressure is constant, the work done is given by this formula. This formula is only valid when the pressure is, yeah.
The different processes are not on the final formula sheet.
Ah, really?
PHYM3
Well, okay. Yeah, I know. Because final formula sheet, I have make it like the midterm form. It will going to be 2-3 pages. So I put everything dumping in, even the description is not there. So you better go to the midterm formula sheet and be confident of what you're doing. Right. Let me look at it. Yeah. Good that you told me. Yeah. They are just there, but they are not ordered, right? It's just dumped there. No, it's there. Look, isochoric, it is there. But I made them everyone, more, nothing, no description. But I have at least put them in groups. Okay, thank me. Okay, right. So, see, I just put without any description. These are all for isochoric. These are all for isothermal. These are all for isobaric. Yeah, I have grouped them. So, yes, good for you. Right. So, see this isobaric, the work done is a minus. I almost forgot to write. I didn't write the minus. And I put the minus. Yeah. Okay. I did put the minus. Do not ignore that negative sign. Okay. So, this will guarantee, as expected, when delta V is positive, work done is negative. Expansion, the system is doing the work, not from outside. So that means a negative work. Because the definition of W is the work done from outside, work done by you from the external agent. What is the work done on the system? That means from something outside. So if it is an expansion, actually the system is doing the work. It is pushing the piston out, our model system. So that makes sense now, right? It's just a matter of substitution now. Minus constant pressure, it is 150 kilopascal. So don't forget the 10 to the power 3 to make it Pascal. And delta V is 25 minus 10 liters, but it is liters. So you have to convert it into meter cube, you have to multiply by 10 to the minus 3. But the good thing is the 10 to the plus 3 from kilopascal will cancel with the 10 to the minus 3 from liters. So if you know that, if you remember that, kilopascal liter is the same as Pascal meter cube. So you can just, if you have it in your mind, you will not even bother, you will just multiply and you know it is going to give that in joule. So I hope you get this answer, right? I don't have to do it myself. I don't even have the calculator to show you. So let me go to the next question. Number 22. Find the work for an isothermal expansion from 1 atmosphere to 0.1 atmosphere for 10 mole of an ideal gas at temperature 0 degrees. So it's a state question, right? We are changing from state 1 to state 2, the change in the state. So that means all you have to do is just close your eyes and write this. This is the best way. This is general. It's true for any ideal gas, okay? Then you pause and see if what is special in this. What kind of isobaric, isochoric, isothermal, isothermal, it is saying there. That means N T1 equal to T2. And there are no leaks in the system, okay? It is the same amount of gas. So N1 is equal to N2. So it boils down to Boyle's law. That's it. So let's see what is given. P initial is given, P final, P1 is given, P2 is given, V. N is given. Oh, sorry. Okay, right. This is the bad thing. You know, I think I know the question already. The question is find the work done, right? So we are in the, yes, the work done for isothermal expansion, you have an equation. Okay, the question is the work done, not to find the volume or initial or anything like that. What is the equation? Go to the formula sheet and you tell me. So I did all this unnecessarily. So this is the bad thing about not reading the question. I read it, but anyway, I didn't pay attention. Simply, there is an equation for the work done. There is a negative sign as well. Ln V final minus V initial. Somebody check me. Did I get the equation right? Isothermal process, the work done is given by this. Because when is isothermal expansion, the pressure is not constant. Not necessarily constant, right? And the pressure changes. So can I use W is equal to minus P delta V? No, that equation only when the pressure is constant. Here, this is not a constant pressure process. So we need to use this. Do I know everything in here? Yes. The N is given, R, if it is not in the question, it is in the formula sheet. And T is isothermal. So the initial temperature, final temperature, it is the same, isothermal. So T is given, but that must be in Kelvin. What about this? So that we are going to need this guy. Although it is not wasted. We are not going to need this. Tell me why. See, this is V2 divided by V1. V2 is not given, V1 is not given. No problem. So I can rewrite this as W is equal to minus nRT. Ln, you can see from here, V2 divided by V1 is equal to P1 divided by P2. So instead of V2 divided by V1, I will have note the switch of 1 and 2. In terms of V, it is V2 divided by V1. In terms of P, it is P1 divided by P2. Maybe it is not in the formula sheet. The formula sheet only give in terms of V2 over V1. But you know, for isothermal expansion, V2 over V1 is equal to P1 over P2. Since in the question only give us a P1 and P2, so that's it. Now take your calculator. Again, I'm really sad that I couldn't get the calculator, the screen calculator. It is deleted. Maybe, yes, I have it in my pen drive. Oh, yeah, happy. So let me copy this and put it in the desktop. Hope somebody doesn't delete it. Okay, here we are. It's nice to have this, especially with these gas laws. It's become very useful using the solving mode and the fractions and all. Yeah, you got it? Good. Let me do for the sake of, because I'm recording this, someone can, who did not come, make use of it. Right. I use this negative for this negative, don't forget that. It is not solving, it's a calculation, standard calculation. N is 10, multiplied by R is 8.314. Is that correct? Right, yeah, 314. Multiplied by T. T is 0 mean it is 0 plus 273.15. So it is 273.15 multiplied by, use the fraction sign, yeah, ln, then the fraction P1 divided by P2. Now, you don't have to convert it, right? As long as they are both in the same unit, it doesn't matter whether it's atmosphere, Pascal, or whatever, as long as you keep it in the same unit. P final is 0.1. We need the P initial first. 1 divided by P final is 0.1. And close the bracket. That's it. Calculate it. Okay, that is correct, right? Right. Let's go to the next one. Yeah, sorry.
We can substitute K for all of another K, right?
What is
The
that?
value K, the constant. We could substitute it for the beginning, right?
K?
Yeah.
What is K?
I believe it's
Boltzmann constant?
I think so.
Yeah, why? You have to be careful about what you are talking about. Do I have K here?
No, I meant that's negative NLT as
I'm not following you, sorry.
the RT, I believe.
Yeah, I know what you're talking about. If I hope so, I think so. NR can be written as N is the number of moles, right? N is the number of moles. You can write it as number of molecules multiplied by Boltzmann constant. Maybe you did that like in your chemistry or something. Maybe that's why you are getting confused. Is that what you are trying to tell me? K, you said K, right? Which is the Boltzmann constant. Boltzmann constant and the gas constant are related. Small n into gas constant is equal to big N, which is the number of molecules, not number of moles, multiplied by Boltzmann constant. Okay, but I mean, we don't talk about the Boltzmann constant at all, at least in my class. So just don't even, just ignore that. Okay. Number 23. A gas undergoes a process in which 5,000 joule of heat is removed from it and 2000 joule of work is done on the gas. Now, what is this about? First law of thermodynamics. And do you know what's first law of thermodynamics is? It's a conservation of energy. If there is any change in the energy of the internal energy of the system, it has to either come from kinetic energy change. I mean, let me put it another way. If the system is isolated, Ke plus, I'm sorry, no, wait. The first law of thermodynamics, right? First law of thermodynamics. So, is either the work you do from outside, the work can be through the work, also through heat. So you can change the energy of a system by providing energy either by doing work externally or by heating it, by putting in a reservoir so it can get the heat energy. So this is called first law of thermodynamics. Usually we write the Q first. Let me stick to the convention. It doesn't really matter anyway, because then you remember in a certain way, right? So let's write always in the same way that appears. Q, by definition, is the heat into the system. And W, by definition, is the work done on the system. Does it mean, it is always work has to be done on the system? No, sometimes the system is the one who is doing the work. In that case, the W will be negative because W by definition is the work done on the system. But if it is the other way around, that means W is equal to a negative quantity. So, right. Okay. Now, a gas undergoes a process in which 5000 joule of heat removed from it. What does it mean? Q is equal to minus 5000. Do you understand that? Okay. Because not heat into the system, but heat is coming out of the system. And 2000 joule of work is done on the gas. So that means this is positive. So we know what is the change in the internal energy. Okay. So if it is a positive quantity, energy increases. If the negative quantity, energy decreases. Now what do you have? Minus 3000. So delta is asking what is delta U. So we are getting a negative answer. What does it mean? The energy of the system decreases. Figure shows a cyclic process carried out in a gas. Which of the following is an accurate statement? Right, so this is what the last slide in that chapter. If it is a cyclic process, for a cyclic process, which can be proved in a PV graph, pressure versus volume graph, the magnitude of the work done will be simply area enclosed by that cycle. For a cyclic process, that means you're starting from some point and come back to the same place, a closed path. In the closed path, that is called the cyclic process. The magnitude or the absolute value of the work done is simply the area enclosed by the cyclic. That's it. So it's a simple statement question. That is, I have to tell you, since we are here, fine, this is the absolute value or the magnitude. What about the correct value? How do you know whether it is positive or negative?
Whether it's expanding or
no, it's a cyclic process. You come back to the same place. The work done is the area enclosed, not the area under the curve, okay? Because we are talking about a cyclic process, which can be proved from the area under the curve, for all three processes, then it can be proved. But my question is, area is the absolute value or the magnitude. So how do I know whether to put a positive sign or negative sign for an actual process?
if the system is doing the work or the outside force is doing the work.
Yeah, but how do you know that?
Should be given if it's not absolute value.
You look, because cyclic means you start from one point and come back to the same point. You can either do it clockwise or counterclockwise. You cannot put this, if it is a cyclic process, can you say from here to here I go like this, and from here to here I go like, you cannot, right? You end up here, then that means you have to go like that and come like that. Now this is, you are going clockwise. So there are two possibilities. You can start from A and come back to A either by going clockwise or going counterclockwise. So two possibilities. When it is clockwise, the work done will be negative. That is what you have to remember. Okay, this is not in the formula sheet. In a cyclic process, if the process is a clockwise process, you get the area enclosed and put a negative sign. If it is a counterclockwise process, you get the area and put the magnitude of the area and put a positive sign. Will you remember that? It is not going to be in the formula sheet. Formula sheet only give you the formulas. Same as torque. Yeah. So the same convention, but it happened to, yeah, okay, you have to be careful. P must be y-axis or vertical axis. V must be horizontal axis. If the axes are switched, it will be other way around. Okay. Anyway, we always have the P in the vertical axis, P in the horizontal axis. Number 25. Now we are going to chapter 16, the electricity. So let me so we have two charges, Q1 and Q2, and Q1 has just one positive unit and Q2 has three positive unit, okay, of charges, coulomb or whatever. Let's say coulomb, 1 coulomb positive for Q1, 3 coulomb positive for Q2. And there's a scale all drawn to scale, okay, there's grids. And the arrows, the forces are indicated by arrows and all drawn to scale. And he's saying on Q1, the force is shown by this arrow. I really need to magnify it because very small. Because you need to count the grids now to get an idea of the forces. Okay, now it's clear, I hope. So if you count the grids, it has got 6 grids. So the force on Q1 is to the left and it is 6 grids long. Okay. Right. And he is telling we make changes to the charges on Q1 and Q2. You take one charge from Q2 and bring it to Q1. So before it is 1 and 3, now it becomes 2 positive and 2 positive. Because I move one charge from the Q2 and bring it to Q1. So both of them are now equal, 2 coulombs and 2 coulombs. Before it is 1 coulomb and 3 coulomb. What will happen to the force on Q1? Will it change direction? Before positive will be repulsion, right? Now also positive. It will still be repulsion. Direction won't change. The force on Q1 will be to the left. May I ask, what will be the direction of the force on Q2? To the right. Okay, they will be pushing each other away. And for the initial situation, what will be the amount of force? If this is 6 grids, this will also be 6 grid or more. Newton's third law. If 2 exert a force of 6 Newton, the force of 1 and 2 will also be the same. You can argue how come, because this is a strong guy with 3 Coulomb charges, is only 1 Coulomb of charge. No, it doesn't matter. When I push the wall with 1 Newton, the wall will be pushed back on my hand with the exactly same force. It doesn't matter who is stronger here. If I increase the force, the wall will also increase the force. It will just match all the time. So the forces will be equal. But the question is not that. Now, I am not asking about what is the force on Q2. I am asking, when I make this change from 1 and 3, now it is 2 and 2, still positive, positive. What will happen to the force on Q1? It will be the same or more or less or the same. This is the question now. What is the answer? How do you answer this? Somebody wants to tell me? Coulomb's law. What is Coulomb's law? That is the equation for the electric force. Anyone remember the Coulomb's law? The force is proportional to, it will be mutual force, one on each other. It will be exactly equal. It is equal to the Coulomb's constant, Q1 magnitude, Q2 magnitude, divided by R square. This is the magnitude of the force. So you just need the force on either one of them. They are equal. See, it is the proportion of the product of the 2 charges. So it is symmetric about the 2 charges. The force on the mutual force is the same. Okay, in the first instance, Q1 is 1, Q2 is 3. Let's say 1 Coulomb, and Q2 is 3 Coulomb. So the force, if you just make this whole thing as 1, because we are not changing, right? K and R squared is the same in both places. We do not change the distance between them. What's the time? We do not change the distance between them, and K is a constant anyway. So the only change that is changing is the product Q1, Q2. The product Q1, Q2 in the first case is 1 multiplied by 3. The force now changes because I am changing the charges on them. So if I just make this equal to 1, because we don't have to worry about it, it's the same both places. So for convenience, I will call it 1. Q1, Q2 now will be 2 multiplied by 2, 4. Before it is 3, now it is 4. So that's how it should change. If it is 3 before, it will become 4. But what it is exactly in number of grids? 6, right? So for 3 become 4 means 6 will become 8. Okay, so the force should be having a length of 8 grids, which is D. Count. I don't know. I think D, right? Yeah, it's a bit difficult to count. Yeah. 2, 4, 6, 8. Yeah. D has the length of 8 grids. The combination of 2 separated point charges of opposite sign but equal magnitude is called, so that's a statement question you should know. We call it electric dipole. Question number 27. Electric field of magnitude 2.3 to 10 to the power 5 Newton per Coulomb points due north at a certain location. Find the magnitude of the direction of force on a negative 7.56 microcoulomb charge at this location. So if you place a charge on an electric field, that charge will experience a force, because the definition of electric field is force per unit charge. So you can say electric force is equal to simply the charge, amount of charge multiplied by the electric field. So we just substitute. Q is equal to minus 7.56 microcoulomb. So you should don't forget the conversion. Micro mean 10 to the minus 3. And electric field is 2.32 10 to the power 5. When you do the calculation, you will find it to be 1.75. But the direction, because the charge is negative, the force will be opposite to the electric field direction. So that's what you need to understand. The negative, because you have a charge is a negative charge, the force will not be in the same direction of the electric field, but in the opposite direction. The electric field direction is north. That means the force direction will be south. Number 28. So we have three charges, negative 10, positive 10, negative 20, placed in corners of a square, and the center of the square is where you want to get the electric field. So let me start with this guy. Say I'm going to call it Q1, and let me call it Q2, and let me call it Q3. The electric field from Q1, because it's a positive charge, will be at the center. It will be like this. Let me call it E1. I hope you follow me, right? E1. And Q2 is a negative charge, and it has a magnitude twice the magnitude of Q1. So from Q2, let me use another maybe red for that. It will be towards the, because a negative charge, and it will have a size length twice the length of E1, because the distance is the same, right? Because the electric field depends on not only the charge, it also depends on the R. R is the distance from the charge to the point where you are getting the electric field. But that is not changing, because these charges are at the corners of a square, and we are looking at the electric field at the center of the square. So they all have the same distance. So that will not make any change to the electric field relative to the previous one. So only change is on the charge. So the charge is double. That means E2 will have the double the length of E1. Okay, we will left with one more. Let me use green for that guy. E3. This guy is the same as Q1, magnitude and direction, the sign as well. So this will Q3. Oh, not, it's negative. Sorry, it's negative. So it will be towards it. It will have the same size as E1. Now tell me, how do I solve this? What is the best technique to solve it, the tactic to solve it? Do you have any two forces that are in the same line? What do you mean no? E2 and E3 in the same line, not the same direction. When they are in the same line, it is easy to add them, even though they are vectors. Get my point? Okay. Let me take another color. Black. Now I'm going to add the E2 and E3. That is easy. E2 is the big guy, E3 is the small guy. So E2 plus E3 will be, let me call it EX. Say, I just want to call it EX. The EX will be this. Do you agree with me? Ex will be simply E2 minus E3. So E2 is twice E3. So the result will be having the same length as E3, but in the opposite direction. Now to let me, because I'm replacing the E2 and E3 by you got my point, right? By Ex. Now look at Ex and E1. They have the same length and they are symmetric about the x-axis, if I call the horizontal as the x-axis. So the y component will cancel. You will have only x component. That means the direction will be in the p direction. Okay. So.
Are they magnitude or are they in the direction of the arrows?
Because they have direction, so it's a vector.
Right.
Yeah.
So when joining, adding vectors together,
it is easy if they are in the same line, right? Because it's like this. Suppose you have a box and you pull this direction with 100 Newton and your friend is pulling with the to the left with the 50 Newton. Of course, vectors, but it is easy. You put plus for one direction, minus for the other direction. So 100 minus 50 is plus 50 because they are in the same x-axis or the same line. So that's what I did there with the E2 and E3. They are vectors, yes, but they are in the same axis or same line. I can do a quick calculation without taking x component, y component. But after that, then you have to look at the x component, y component. Question number 29. When a positive charge moves in the opposite direction in an electric field, okay, positive charge by itself will move in the direction of the electric field. Electric field is from positive side to the negative side, right? Electric field direction will be from positive to negative. So if for a positive charge will naturally, spontaneously by itself will move towards the negative side, that means it will move in the direction of the electric field by itself. But if you want to move it towards the positive side, positive to move towards the positive side, that means make it move opposite to the direction of the electric field, somebody has to do work. So that means its potential energy will increase. So that's why this is the correct answer. All the other answers are wrong. So you understand the thought process, right? Why it is so. Suppose this is a negative charge, it's the other way around. Negative charge by itself will move opposite to the electric field. So it will go towards the positive direction. Electric field direction is from the positive side to negative side. Number 30. Potential difference between the interior and the exterior surfaces of a particular nerve membrane is 70 millivolt. If the membrane width is 6 nanometer, find the magnitude of the electric field across the membrane. So membranes are like capacitors. So the two membranes, one you can consider as the positive plate, which is outside usually, and the inside the cell will be the negative plate. So there's a potential difference between the two membrane, say negative inside, positive outside. You know that such a thing, we can model it as a capacitor. This electric field is constant. We even have a we prove it for a capacitor plate. It depends on the surface charge density. So it's a constant, uniform. You can assume there's a uniform electric field. Then we learned when you introduce the potential, is it potential or potential energy? Potential difference. Potential is given by this equation. It's in the formula sheet, I believe. E dot D or minus E D. Okay. So we have the potential difference. Delta V is given and D is given. All you have to just calculate the electric field. Now, these are magnitude here, so you can just forget about the sign. So E and D are parallel to each other because the field is direction is from positive negative. So it is simply just ED. This is given, this is this is not given, this is given, so you just calculate E. So E is equal to delta V divided by D. I think you will get the answer. Can somebody check it for me? 70 millivolt, that means 70 minus 3, and D is 6 nanometers, that means 6 into the power nano, 9, right? Nano is 9. Can you check you get the answer? You should remember these prefixes, okay? It will not be given to you. Nano mean minus 9, right? Sorry. Nano mean 10 to the power minus 9. Oh, I have the calculator. Okay, let me see. Yeah, okay. Thank you. Let me do it anyway for the benefit of someone watching the recording. Okay, that's correct. 6. Can I make it into scientific? Oh, it doesn't work like that. Okay. Yeah, it's correct. Yeah.